Okay, welcome back. Today on my bench I got a real treat, something I've been looking forward to for a long time here. This is a Harman Kardon Citation 15 FM tuner. A standalone FM box that has no AM on it. Citation series, you know it's good if Citation has its name on it. Nice unit. It's, I don't know, mid-70s I'm assuming. It's got some nice features, external Dolby noise reduction, provision for that. It's got a provision for an internal tone generator. I think it's like 400 hertz, and it produces a set level tone, so you can use that for aligning your tape decks. Mute button, independent left-right gain controls, stereo mono, and it's got a stereo filter. And it's and if I'm familiar with any of the other Citation equipment, this one is no exception. It's going to have some pretty intense tuner circuitry in here, because Harman Kardon didn't cut any corners on their Citation line. Let's have a look at the back. I got this on eBay. It was a good price, a very good price. It's heavy, very heavy. So we have two outputs, a variable output, which is from those two gain controls in the front, a fixed output, your Dolby in and out, some adjustments for your muting and threshold, stereo threshold, inputs for your antenna, 375 ohm. There's an output for quadraphonic decoder, something that was big back in the 70s, I guess. Everybody was pushing for quadraphonic, and instead of building that in, they provided an output on the back, so you could have an add-on decoder, and then the usual fuse and outlet. Not much going on here. There's no ventilation holes, so it should be nice and clean inside with no dust. I'm gonna say it's a working unit. I don't know. It's very heavy. Let's get a bench amplifier here and hook it up. Alright, we got it hooked up. I got a PM640 integrated amp as my bench amplifier right now. Let's turn this on. Got it set for tuner. Controls are all set. Turn this thing on. Oh, looks like we have an oscillation. So what's going on here? It's the left channel. Right channel is pretty quiet. Dirty switches. That's working on one channel only. The other channel's not making any noise. It's a little bit of ticking. I bet you it's coming through the power supply. This left channel's got a bad oscillation. So yeah, looks like we got some work ahead of us. Not good. Okay, well, let's open it up, see what we can do. Wow, something going on there. Okay, so there's my indicator lights. The main tuning's working. It seems like a burnt spot here on the meter. This one's completely out, and this is completely out. So we've got a little bit of work here. Okay, let's have a look inside. Very heavy lid, heavy gauge. A nice clean design. I like this. You don't see that very often. Wow. This thing's got some age to it. I'm trying to figure out what year this thing was made. Looks like there's connectors coming from below and plugging into the boards. Each board is removable. These fancy nuts. So it's going to be a recap for sure. I'm pretty sure of that. So maybe we should try the recap first, and then see what kind of response we get out of the tuner after the recap. You just have to take the bottom off. Wow, look at that. That's impressive. That is really impressive. Look at this stuff. That is a nice design. Looks like we got most of our heat here. I'm suspecting all these caps are shot. I like this sticker here they have on the top here. So what it's telling you is don't spray anything in those sliders. But we'll see how clean they are. So I think before I do any troubleshooting whatsoever, I'm going to do a full recap on this. Just because in the past when I've done a full recap, usually all the gremlins go away. And I expect that kind of will happen here too, to an extent. But a lot of these axial capacitors I don't have in stock. I'm going to have to order these. So I'll go through and I'll make a list of all the capacitors I need, and I'll get that ordered up. And then once that order gets here, I'll go through and start recapping these boards. There's two boards here, 3 on the top. It's very nice, clean design. So we'll go through and we'll do that. And then once I get the recapping done, we'll start seriously looking at what's wrong with this thing. Look at this wheel. 5 inches in diameter. It's made of like cast iron. They didn't scrimp on anything here. Incredible. Just going through, starting with the recapping. And this is the first board I pulled out. I think it's something to do with the FM demodulator. But anyways, this is what I found. And you can see that. Here, let me show you. Right here. There's a big crack in the board. And that's through the copper, yes. That's one of the mounting holes. So, you gotta keep your eyes open for stuff like this. These boards are very brittle and they'll crack. But it looks like it's in the middle of nowhere, no man's land here on a ground plane, so it's okay. But just got to keep my eyes open for more of this stuff. Okay, I'm just going through and checking out these boards. This one here has on this transistor, this series pass transistor for the voltage regulator power supply circuit. It's got a cracked emitter joint, and it's cracked right through. It's completely broken. But yeah, there's some of the soldering on some of these joints is really questionable, and it looks like it was wave soldered. But and it looks like on some of these somebody came up after and cleaned up all joints. So it's been early days of wave soldering, but we'll get that sorted. And also I'm noticing here, for example, on this board, it's got kind of a coating on it like a grease. Now you see it, it's somebody sprayed something on all these connectors, and it's a green, oily, waxy substance. And I'm beginning to think it might be deoxit, but I'm not sure. But yeah, all these connections were sprayed with something, and it's seeped into the board and all over the components. So other than that, I'm not finding much. Just waiting on those new caps, and then we'll get this thing recapped and get going again. Alright, so I've been lots of work going on behind the camera, or off the camera, sorry, on these boards. I went through and recapped them all. You can see that, recapped. Checking the capacitors, found 7 of the 25 were below spec or not meeting spec. So they're gone. I don't know if that was part of the problem with the oscillation or not. Another problem I found, 19 resistors failed to meet tolerance. These are all out of tolerance. These are 10% resistors, and they're all outside the 10% allowance. So they're gone. And I found a shorted transistor, base to collector short. This was on the muting and, what is this called? Muting and meter board. So it's not in the signal path, but it handles the meters on this unit. And it's a PNP transistor, and it's an old Motorola part. What I'll have to do is PNP. I don't know why they use so many PNPs on this board. Actually, they're all PNPs. It's weird. But I'm going to dig through my vintage collection of transistors here and see if I can find an equivalent. On the schematic, it says you can substitute a 2N3417, and I'll see if I have one of those. If I don't, I'll just get a generic PNP transistor that meets the specs. Since I don't think there's any signal processing on here, I think it's just all meter control and the muting for the 2 meters and whatnot. So I don't think it's a critical transistor, but I've been doing a bit of reading about these tuners and these American parts that they used, and eventually these transistors will start failing. They're 45 years plus in age, and these are transistors from the early era of transistorized products, and reliability of these aren't great. You know, even though they are brand name, they're Motorola transistors. It's just technology and transistors has come a long way in the last 45 years. So I'll get through that. I'll get the transistor selected and installed, and then I can start reassembling the boards back onto the chassis, and we can do a power up for the first time, see what we got. I expect it should be working. Let's hope. Oh, one other thing I found on this board, Q922 is the one transistor I removed that's shorted. Okay, that's fine. Q913, which is on the other end of the board here, I found a base to emitter short from a solder bridge, and it looked like it was a factory soldering. So either somebody went through here and resoldered all this, which I kind of think what happened, and then they bridged that transistor. But it's funny they didn't find it. But I picked it up on the VOM with the diode checker. So clean that up as well. So there was 2 shorted transistors. One of them was a bad transistor, one of them was a bad board solder joint. So I'm trying to date this thing, and from what the documentation says, this thing was produced 1973 and beyond. But if you look at this chassis, this is typical of tube chassis. You know, you got your steel box, and you got all your components, your wiring on the bottom side. Top side is your components, like your big components, your electrolytic capacitors, your tubes, transformers, everything's on top, and then you have your wiring harnesses. These wiring harnesses were built on a loom. You see they probably had a jig, a piece of plywood with nails in it, and they would produce the harness by, running wires of certain colors, certain lengths to certain locations on the jig, and then they would zip tie everything, and then they would remove it as one piece, and then they would install it in the chassis and solder it in. And that's typically how they did things back in the day with tube equipment. And I think this is built, is built in an American factory. This is before they moved all their production over to Japan. They were still building in the American factories, and the American factories were tooled for tube equipment, obviously. And this is like a bastard child, if you really want to think about it like that. It's built in an era when they still had all their tooling and their mindset on tube equipment, but they're trying to produce transistor stereo equipment. But this is what you get. You get these modular boards with these horrendous plug-in connectors. They're probably notorious for all kinds of bad connections and flaky signals, and it's probably a nightmare. But what do you do? That's what they did back in that era. Now I got a lot of grease and stuff on these connecting pins, and I think somebody sprayed it with some kind of maybe it was sprayed with deoxit, but you see it's this green kind of grease on there. Maybe it was an oil once upon a time, but now it just comes back as this awful grease. It's something you don't want in a connection, actually, is grease, because it's an insulator, and it prevents your oxidation. It prevents electrical connection as well. So I don't know, I think I'm going to clean all these off. Yeah, this is just, I'll clean all these off, filthy there, and reassemble. These connectors themselves, they have, I'll pull one up. You can't really see it on camera, but if you look into these connectors, there's 3 fingers. Yeah, I get a good shot. There's 3 fingers pointing inwards to slide up against this pin. And if you really want to make things better, you go in here and you bend these fingers so they make a better contact with that pin. But eventually, these are tin plated, and these are tin plated. There's really nothing you can do about oxidation over time, apart from just totally disassembling it, cleaning it, and putting it back together again. That's your best bet. But I'll clean all these off, and I can't clean in here without getting some kind of spray solvent, maybe a brake cleaner or something, and take them outside and spray them with a brake cleaner to get that green grease out of there. But I'll just clean it the best I can, reassemble it, and then we'll go from there. If we have problems with connections, we'll troubleshoot and we'll fix that. But I have a feeling it's going to work right out of the box here. I've sorted out 2 shorted transistors, about 20 some resistors that were out of tolerance, and I replaced another 7 bad caps with good ones. So I have a feeling it's going to be a success, but I just wanted to point out how they were building things back in the day. The point-to-point wiring. This is all typical of tube apparatus. Oh, another thing. Look at this that I noticed. I'll show you here. Crank the camera up a bit. If you can see this here. Right here they have a plastic grommet going through the chassis to protect the wires. That's what you want to see, right? But if you look down here, there's nothing. It's just a sharp, and that's razor sharp too. This it's been punched out, the chassis, and they have the wires. And both these holes are just going through this sharp, unprotected hole, and this is where the power transformer is sitting right above here. So this is your primary, this is your secondary windings coming back, and they're all just put there with no protection against cutting. So I'll have to get a grommet or something for these two holes and fix that up. But I'm surprised they let that go at the factory like that. Okay, time to move on to these meters. They're kind of, I'm not happy with these meters, but I'll show you what's going on with them. If I can find my stuff. Okay, here's a flashlight. And I'll show you what the meter looks like from behind. You can see that dark spot there? This one's not as bad. It's got a little bit of a dark spot. But you see what's going on here is the back of these meters got cooked by the incandescent lamp that was put behind it. And you can see the plastic's all melted, kind of half melted and sagging. So what I'm going to do is this one. I'm going to disassemble this and see if I can resurrect these meters to look better. Of course. Okay. So what it is, it's a black plastic mat that's glued down. Actually, what I'm going to do is I'm going to take this, remove this movement first so I don't damage it. So let's put this back together. Just protect it. And then I'll get these wires removed. Now, oh, I found a date code, by the way. You can see that date code on there. It's 1972 4-0. So I'm assuming this is an early model. All right. I believe it's just held in with one screw. So I'll remove this one screw and see if this pushes out. It does. Very nice. Take that, put that aside. Don't want to wreck that part. Okay, now we can work on this without worrying about damaging things. Okay, so I'll clean all that glue off, but it's still, yeah, I don't know if we can fix this. It's cooked. It's definitely cooked. I'll see if I can get that glue off. Okay, so I cleaned off the adhesive, the double-sided sticky tape from the back, and half of it was dried up and crusty, and half of it was still sticky. It's kind of a pain to get off, but some alcohol and some elbow grease. But bad news. You can still see that this is discolored. Here, I'll show you. Can you see that? That plastic is cooked to the point where it's, you know, light won't pass through it. And yeah, I don't know what I'm going to do with that. I was going to hope that was not the case. All I can do now is reassemble, and I'm going to be using LEDs in behind these meters because you can't put these incandescent bulbs in and have them cook like that. But I'll put some LEDs in there, and it's going to have to do. The only other thing would be is if I made another faceplate, and I'd have to, I don't know if I could do that with having it look half decent. I don't know how I'd go about that. But so we'll reassemble, and there's not much we can do with this. I'll clean this off. Let me see how this looks together. Yeah, it's still see, even this got cooked here. I was thinking if it was the meter case, I could cut this open and put a piece of white plastic in here just to keep the dust out. But it doesn't look like that's going to help me at all. This quieting meter is not as bad. It has a little bit of discoloration, but I'll show you. Maybe you can see it's barely noticeable, right around between the 5 and 4 mark. Yeah, so I'm going to leave this meter alone. I'm going to put that back together. I'll disassemble it and clean it because there's, the inside of the lens is foggy, and so I'll deal with that. But this one here, I'm not going to be able to resurrect. And you can see that it's got that dark spot. It's pretty bad right at the on the plus side. Not much I can do with that. Replace it if I found another meter, but what's the likelihood of that? So I'll do the cleaning, reassembly, and then I'll get some LEDs. This is the housing for the lamps. Give this a polish, clean up, and I'll get some LEDs, and we'll get this lit up. There's another lamp behind here. I'll have to take this out. I think I can get a screwdriver in here. I should be able to get a screwdriver in there and get those 2 screws out, and then I can pull up this lamp assembly. I want to give these numbers and the scale a cleaning because it looks really dirty and dusty in there. And then we're going to do an LED retrofit on that one too. Okay, I got the aluminum faceplate here. I got some nasty nicks here right on top. I got one here, here, little ones, and I got a big one here. So this is how I clean them up. I know people are going to scream at me, but I don't care. This is what I do, and when I'm done, people don't even know what happened. So you get a file and just run it along the top, the full length, and just keep your file square. Knock off all the filings. You don't want to do this with the faceplate on the unit because you'll get shavings inside. See, I'm getting quite a. There's a couple here that are showing up. They're quite big dents. This side, I got a dent here, but I'm just going to keep going. And just keep filing. And try and keep it even as possible, straight. Until you don't feel those anymore. Now this one's gone from the top. I can see a little bit on the front here, but that's nothing I can do about that. And then when I get to the point where I'm happy with it, just clean off all the Now what I like to do is just take a scouring pad and just brush the top with it, just to smooth it. And then it gives it that finished look. Smooth, and all those nasty nicks are gone. You do this on the bottom too. I wouldn't recommend doing it on the front because you could actually screw up the finish here. I don't know if they have a coating on here or not, but the silk screening is definitely on the aluminum. I don't know. Anyways, that's how I clean them up. Yeah, it's a lot better now. I could, before you cut your finger on it, like right here, it was really sharp. Now it's smooth, and you can hardly feel it when you go by. And clean it up with one of these pads, and it gives it a nice, almost a factory finish. And then when you're done with that, just clean everything with glass cleaner. Get rid of all that aluminum dust. Yeah, it's much better. Okay, now that the electrical's done, I'd like to power it up and see if the tuner is working, for one thing, and if any other issues have cropped up. So let's just turn this on. I got it all connected to the tuner. Meter movement. We have a hiss. It's very quiet hiss though. There's our tone. Dirty switches still. It went into stereo because I heard the separation, but the light's still not on. Same thing, there's stereo. This tuning meter is not really doing anything, it's just staying still. Getting a hell of a 60 hertz hum too, so I might have to go through and check the power supply one more time. I checked this cap, it was acceptable, but I bought new caps to replace this one. This is three caps inside this one can, and they're 1000 microfarad, 1000 microfarad, 100 microfarad, and if I have to I'll change it, but still have a nasty hum. And it sounds like the tuner needs a good alignment because it's really not picking things up good.
This one's for you. I don't know for real. Next time, guarantee the truth will get revealed. Black leather glove, no sequins. Yeah, I guess a leak. I can crossbody.
Okay, so at least I know what I'm up against. Alright, now it's time to move on to some of the lighting changes I want to make here. But first of all, the FM stereo indicator lamp was burned out, so I put a new bulb in. It's just a regular 12 volt 70 milliamp incandescent. And the same goes for the front panel. The front panel power indicator, that bulb was burned out as well. That was another bulb identical to this one. It's 12 volt 70 milliamps, 60 milliamps. So what I did is I'm trying to get this lit from behind. They used to have these god-awful bulbs that sat behind there, and they created so much heat that it cooked the masked scale here, and it put a burn spot on it. I don't want that to continue. This one's not as bad, but this one's the worst. But I'm going to get rid of these incandescent bulbs and do some LEDs. And what I've decided to do is, in the housing for the bulbs, is I just put an LED strip. Now this is the stuff you get, let's see if I can have it here. This is just the LED strip you buy off eBay or whatever. It's the cheap Chinese stuff. Problems with this? There's a number of problems with this, to be honest. They all say that they have 3M double-sided sticky tape on the back, but it's not 3M. It's a cheap knockoff sticky tape. So this sticky tape on the back, it's even coming off right now, has a real problem sticking to surfaces over time, and usually comes off, and you see these strips falling off and whatnot. The other problem is they use garbage LEDs in them. And if you look with a magnifying glass at the dies of the LED, you'll see that they do not use gold bond wires. They use like an aluminum bond wire or something. And that's a problem over time too. If you run these at full current, full voltage, they tend to heat up. If you run, these are rated for 12 volts. There's three diodes in series, and then there's a 39 ohm resistor to cut the current down. And it's designed to run off 12 volts. But if you run it off a supply that's 12 volts or higher, which most are, these run at overcurrent, and they usually heat up more than they should, and the tape fails, and then the bond wire fails. So my plan is to run this at a reduced current, and hopefully I'll alleviate those two problems of, one of them is the tape letting go, and the other one is the bond wire failure. In bond wire failure, you see the LED starts to strobe and flash. That's a bond wire failure. So anyways, I'm going to run this at 11 volts, and what I've done is hooked up to a power supply and checked how much current it draws at 11 volts. So I turn this on, then we got our LEDs, and we'll see how it looks once it's installed. And we got our 2 meters. Ignore that light. But this looks good. That looks a lot better. So I'm happy with that at 11 volts. Now, at 11 volts I'm drawing 70 milliamps. Problem is, this needs direct current, and it needs to be a steady direct current, or else you get strobing. Like if you move it, you can see strobing, which I don't want. So what I have to do is I have to build a little circuit to take the AC voltage that was previously fed to the bulb and convert it to DC and regulate it. So here we go. What I measured here on the tuner is when it's turned on, it's the transformer supplying a full 14.6 volts to those bulbs. 14.6 volts. So I want to rectify that to DC, so I put a simple half-wave diode rectifier in there, and that's automatically off the bat, that's going to drop it by 0.6 volts. So we're dealing with 14 volts. And of course, when we do that, we have to consider RMS and peak. So when we rectify it and filter it, it's going to turn into a peak voltage. So what I'm working with is 19.8 volts DC that I have to knock down to 11 volts. So the difference between 19.8 volts and the 11 volts that I want is 8.8 volts. And this is what we have to drop with a resistor. And our current is 70 milliamps, 8.8 volts. You use Ohm's law, R equals E over I, and it comes out to 125 ohms. That's what we're going to need for this resistor. So this one's a 125 ohms. Now, just slapping any old resistor in there is not going to do, because if I calculate how much current is going to be going through here and how much voltage across it, we're going to get a wattage, right? It's going to be dissipating heat. So 8.8 volts with 70 milliamps, we're going to be getting 0.616 watts, which is over half a watt. So if I whack a quarter watt resistor in here, that's more than twice its rated wattage, and it's going to burn out. I do have 2 watt resistors here. I'll probably use one of those just to keep things cool. I got 120 ohms, which is the next closest standard value, and I'll even pick out one that's maybe a bit higher than 120 ohms just to keep it happy. This shows the 2 strings of LEDs in parallel. Parallel. That's how they're wired on these strips. Everything's in parallel. You got 3 LEDs, a resistor, dropping resistor, 3 LEDs, dropping resistor, and then 3 LEDs, dropping resistor. That's how they're wired. They're all in parallel, and they're in strings of 3. So here's my LEDs, strings of 3, the 39 ohm dropping resistors for the string. Half-wave rectification, 125 ohm dropping resistor to limit the current and voltage to the strings. And I'm adding a capacitor here just to get rid of some flicker, because when you do half-wave rectification, you're going to get a pulsing DC. So I'm going to add a capacitor in here, probably, I don't know, 220 microfarad, maybe a 470. I'll try the 220 first and see how it works. And this circuit should take the 14.6 volts AC, knock it down and rectify it, and provide the 11 volts that this needs, and keep this nice and cool, and keep it living long, so that this doesn't go out again, and this doesn't get burnt again by the heat from the bulbs. And then after that, I'll have to figure out this. This is white. There's no color in here. Let me get rid of this for a sec. The bulb I pulled out of here is working. It's a white incandescent bulb, but it has the condom on it, right? The blue condom. Let's get it off. But this bulb is shot too. It's pretty much overheated. Let's plug this in. I'll show you the difference. Turn it on. See, now if I just put LEDs or an incandescent in behind here, it would be white, which is not the color we want. We want this condom on it, and then it gives it that green color. So what I might do here is, I can't use white LEDs, otherwise I'll have to get some kind of green filter to filter through the light. What I might have to do is get some, see, that's getting hot already. I don't like this. It's awfully bright too. These are 12 volt lamps, and they're run at 14 and a half volts, which is why they get so hot and they're so bright. But anyways, like I was saying, I want to get this the same color as this, depending on, get it close anyway. I'm going to see if I have some green LEDs that'll work, that will kind of match, but we'll come to that. And when the time comes, we'll figure that one out. I'll just get this one first. Alright, so I got to build a little circuit here. I got tie strips. Lift this up. I got a tie strip here with some empty lugs. I can use some of these empty lugs to put a diode and a resistor and a capacitor and build my little circuit here. Run the wires to the LEDs in the housing, the lighting housing, and do it that way. That's probably what I'll do. So I'll get on with that now. One thing I'd like to do before I get too far into this with the dial lights and the front panel, I still have to take all these switches apart. Some of these are filthy, I have to clean them. And the only way to do that is to take them out and take them apart. But first I want to do is I want to deal with this tuning dial. It feels really stiff, and it should actually move a lot freer than that. And I think it's because the grease in the mechanism, in the reduction, is gummed up, and I think it just needs to be taken apart, cleaned, and re-greased, and that'll work a lot better without, because it feels kind of sticky. It has a unique gear reduction. It's not a gear reduction, it's actually a ball bearing reduction. I'll show you how it works here. I got another one I can show you, just hang on. Okay, I got one here. This is out of another radio. This is out of some other radio, I don't know what it is. But this is a unique device. This thing here, this part here gets anchored to the chassis and gets tightened up and secured. So this is fixed. Remember that. This is fixed all the time. So, and it has coaxial shafts on it. It's got an inside shaft and an outside shaft, and this has a flat on it so that they can put a knob. But what happens when you turn the inside shaft is the outside shaft moves at a slower rate. You see that? Now remember, this area here where it's hollowed out, let's say, or it's reduced, that is where they put the dial cord string. They put 3 wraps of dial cord string on there, and that transfers the rotation into linear movement for the dial cord. But you see how if I turn the outside one, how the inside one travels at a faster rate, and if I turn the outside one, the inside one travels at a slower rate. That's because they have ball bearings in here, and the ball bearings act like a reduction gear, kind of, one rolling against the other. I don't know if you can see it in there. I'll try. You see the ball bearings turning, and there's a little cage. The outside shaft has a little cage with holes in it, and then each ball bearing is occupied in one of those holes. And as it's got grease in there, and as it turns, the ball bearing rolls and turns at a slower rate. It's kind of like a little planetary gear almost. But the problem is the grease gets all gucked up, and it's pretty sticky. So I think that's what's going on with my tuning knob here, is the grease is all caked up, and I'm gonna disassemble it and re-grease it and put it back together. Now before I disassemble the tuning indicator and knob here, I'm going to need to remove the dial string. What I have is I have the dial set to 0. There's a 0 mark here, and that's as far as it goes. And the capacitor is fully meshed on this side. I'm not going to touch that. And I want to put a mark here somewhere on this wheel and this housing to reference each other back, so that when I put it back together I can get it right. So let's put a little scratch here. And a little scratch on the wheel to coincide. Good enough. So I think all I need to do now is remove the dial string. And what I'll do is leave it like that. Got a 1/16 hex key. Just loosen off these 2 set screws. And this can come off, and I can set it aside. Now I got a bearing here. What I need to do is remove this top cover. So it's 3 screws. One. It should be free. But we got a problem. We need to remove the front face. It has to come forward probably a 1/4 inch just to get it past that. So I'll take these 2 screws out. I'm gonna have to do the take the front panel off anyways, I think, because the front chassis panel, because oh, there's one under here. I want to do the switches anyway, so it's gonna have to come apart. So that's perfect, I think. That's good. Take this out. All right. I got a bearing up here. Sounds dry. And what do we got here? So I'll have to take this apart further. I think I got some set screws here. I'll take these set screws out and see what it does. That one was loose. There we go. So we got the dial out. You can see these cracks here. There's cracks in the plastic around the shaft. See those crack? And there's a crack here. Thankfully it's not falling apart to that point yet. I think this is okay. I don't have to do anything with it, but if it was in worse shape I'd probably have to get the epoxy out. So now there's a flange here holding this to the chassis on top, and then on the bottom there is I got the bottom of the chassis. This board's in the way, so I'm taking this board out. There's one nut. Pull this out. Put this aside. Now that gives me access to these 2 nuts. Take these out. And off comes the bottom support. There's a little, it looks like a ball and socket joint here. The nylon washer or bushing. And that's dry. And then we have our flywheel attached to the reduction. So I'll pull the flywheel out. 2 set screws. That one was loose. And that one wasn't tight either. So how many set screws do I have here? Just 2? Still stuck. Okay, I got the wheel off. What I had to do is I had to whack the end of the shaft with a plastic screwdriver to knock it back. This this grease is so sticky. It's like I don't know. It's really holding it on there. So now I'll just flip it down. I'll remove the 2 screws holding this to the chassis, and then I'll take it apart and lubricate it. Look at these screws, how they're stripped. That's from the factory. I doubt anybody's taken this apart before me. This one's not bad. This one is completely rounded out. If I can get a bite on it. Oh, there it goes. Get some new screws. That's ridiculous. So you look at this, it's very sticky. It's got grease. I don't even know if this is grease anymore. But it's so sticky, and I'm just gonna redo this with take it. I'll spray in some brake cleaner or something. See if I can clean that out. All that old grease. I don't want to disassemble it. I'd have to bend up these 6 tabs, and I'd rather not do that. It'd be easier if I could just spray in some cleaner, work it, spray in some more, work it, and do it that way. Clean all the grease that way, and then I'll re-grease it with some new stuff, and then we'll reassemble. But yeah. So I took it out and I sprayed it out with brake cleaner 3-4 times, and it's working good now. It's dry. You can feel it's dry inside, like it's. But let's get some grease into it, some fresh grease. Where's my grease? Get it down into where the bearings are, the ball bearings. Let me get some light on this subject too. Okay. You want to inject the grease in between the ball bearings and the shafts, so that when it starts rotating it's in the best place. I think there's 4 ball bearings here. Let's give that a try. Oh, that's nice and smooth now. Let's give it a little more. Let's see. Yeah, I'll need some more. You want to pack it in there good. You don't want to overflow it, but then you don't want it to be dry either. You can see inside there, and it's looking a lot better. Feels a lot better too. See, that wouldn't happen before. It would stop. Now it's spinning free. Okay, that's good. All right, success. So reassemble. I got some new screws here. This is all 632 machine screws, so it's nothing metric. It's all just Imperial hardware. I'm just gonna put this back in, and then we'll slap it all back together. See how it runs. I'm not going to strip them this time. I don't know why they would crank them down so hard to strip the screws like that. Okay, well, that's in. Perfect. Let's reassemble the wheel and everything else. Now that I got the wheel back on, just gonna tighten these down. You don't have to go nuts on them, they just to lock it to the shaft. That's good enough. And the bottom bracket needs a little bit of grease in it. Just on the end of the shaft. Put this back together. Perfect. Now if I was a perfectionist, I probably would have repainted this wheel because it's got some chips on it. It's chips out of the paint, but you know they're on the bottom, you don't see that. The top is a little better. But hey, works good now. I'm happy with that. Let's reassemble the top. Alright, I had to go wash my hands, they're all greasy. I want to, for this part, I don't want to get grease all over the fingerprints. And just want to clean this off and see how it cleans up. Actually, it wasn't very dirty at all. It looks good. The inside looks pretty clean too. A little bit of dust. For the most part, it's good. Let's put these set screws back in. I think we're ready. No, I have to clean this yet. The shaft is still greasy. That's better. What's going on here? There we go. Fully seated. Tighten her down. Okay, I think we're good. That's exactly what we want. I'll put those screws back in. I'll lubricate that top bearing, and then we'll do a realignment. Alright, we're back together. It's working great now. I think that's how it should be. If you want to scan through the band, you should be able to just fling it. Well, it probably won't work that good once we get the dial string on, but let's give it a try anyway. Okay, drop that on there. Now this is the fun part. For the most part, the string stayed on the main drum. I still have to thread this. Okay. All right. Ah! I'm supposed to do that. Came off here. I'm trying to do this so that you can see what's happening. Okay. There. Now. Perfect. That's what we want. Scratchy sounding. Okay. So we mesh the capacitor plates fully. We set the dial to 0 right there. And we should have our marks aligned, which they are. Now we need our hex key, wherever it went. I don't know. Where did it go? Need to lock this together. Here it is. Do this one first. I'll just raise it maybe 1/2 millimeter. Lock this one. We're done. Well, that works a lot nicer. I like that. Alright, let's move on to cleaning some switches. Just so you know, there's a diagram in the service manual how the dial cord should be strung. So it gives you, it's pretty basic. Pretty basic. It's not like some tuners where it goes around here, then goes around here, does a 90, comes around here. This is just straight shot. So it's fairly straightforward. These switches are quite old. I don't know if I would be able to find replacements. But this contact cleaner, Electrosolve, is doing a good job of washing out all this old grease and that sticky mess that was in there before. You can hear it's cleaning up quite nice, and you're clicking nice now. What I'll do is I'll let that dry, and then I'll give it a light coating of deoxit. This is the fader deoxit, and I'll just get this on the contacts only. And then for the switch itself, they're kind of a complex mechanical switch. I'll just lube up the sliding surfaces here and get those back in order. And I got more here I have to clean. And yeah, then we'll assemble it. And this one doesn't even click very good. Got all these switches cleaned and lubed, and they're working good now. They're a lot of this kind of a greenish kind of stuff coming out, but I'm gonna, despite the warnings, I'm gonna hit this up with some detox on these faders, and I'm gonna leave it at that. They didn't need a cleaning, but I'll lube them up. They're dry. Just gonna give it a drop. Okay, assembly, and what else? That's it. I think I'm done. Oh, I still have to figure out a light for the tuning scale, so we'll get on that. Alright, so after much pain in the ass, I got the LEDs installed for the front. White LEDs for behind the meters, green LED, single high brightness for behind the dial scale. That's what it looks like. Probably not accurate representation on the camera. Let's see here. Problem being is this glass is smoked, so I'll give you a better idea what it looks like. I can get that together. That's what it'll look like finished, which I think is a little too dim, maybe. I don't know. It seems to work okay. It's better than before, in that there's absolutely no heat being generated now by those incandescent bulbs. And I like the LED, the green LED behind here. So that's what I'm going with. So that's it for this. I finished with the alignment. I did it the best I could with what the tools I had, because I'll tell you, the instructions they give you are garbage. Here they refer to a transformer, adjust coils L105, 101, which is fine. And then they say adjust T102, T103 for the maximum signal best symmetry. Well, there is no transformer T103 or whatever the hell it was, T102. There's no transformer T102 on the schematic anywhere. And there's a T101, there's no T102, there's no T103. So their instructions, I think they just copy and pasted these from another tuner or tuner circuit that uses the same layout. But yeah, it's, see, it says adjust T104 for best usable sensitivity. Well, there is no 104. I tried, but I got it. I got it aligned. I got the band aligned. I got the upper lower parts of the band aligned. I got the stereo separation aligned. The tuning meters aligned. It's kind of an odd thing, this tuning meter, because 0 is full scale deflection, and I'm not used to that. Tuning meters usually, you know, they're, when you're no signal, you got your needle on the left, but on this, when you got no signal, your needle's on the right, which is, I don't know, understand why they do that. It's kind of back asswards. Other things to say about this? It's a good tuner for its day. It was really a good tuner for its day. They put a lot into it. I don't much care for the old tube style chassis here with the big plate with everything mounted on. This transformer is a throwback from the tube days. It gets very hot, and believe it or not, I measured the secondaries. I measured 100 volts AC. Why would you need 100 volts AC to power a few transistors and a couple ICs? It's beyond me. It doesn't make sense. This gets hot. The voltage regulator underneath gets hot because it has to deal with all this voltage. And you know, this is warm. It has to deal with a lot of voltage. Other than that, the other problem with this I can foresee is these connectors that plug in for all these boards, all these connectors here. Every pin is an opportunity for a bad connection. That's what the way I look at it. If you really wanted to make this bulletproof, I would take these wires and solder them to the board, but then that ruins your serviceability. You wouldn't be able to take these boards off easily, and it would, you know, kind of butcher the originality of the thing too. The tuner is very sensitive. I had to, when I was going through my alignment, I had to put the cover on and solder it back down because that made a difference. With the tuner, with the lid off and with the lid on, there is a huge difference in performance. It has this nice, you can read that, I'll crank it up. It has this nice 9-pole LC tutorial toroidal linear phase IF filter. That's just stuck on there, but this here is something that you'll find in a communications receiver, possibly military grade. This isn't cheap. I'm putting one of these together. Yeah, this is something that's outside the realm of home entertainment. But they went through the process, or through the expense of getting that on that board, and it does do a lot of good for this tuner. I had one problem with this chip. I was just about to start videoing this last segment, and I turned it on one last time to listen, and I had all kinds of garbage and distortion. And what it was is I had a faulty connection on one of those pins. But yeah, it's an old machine from 1975. I like the tuning now. It's very, very nice. Works great. Cleaned the switches. These are old switches, but they had that grease in them, and I washed all the grease out and put in some deoxit to clean these up, and they work good now. Not much else to say about this. A couple of adjustments on the back. It might be confusing for a novice user. You have to set those up yourself. But anyways, let's turn it on and listen to how it performs after it's been tuned up, recapped, and repaired with 20 some odd resistors that were replaced, the 25 capacitors, and one transistor that was replaced. So let's look at this. Alright, listening test. See, I have the mute on.
Dont elle a été victime par son entraîneur.
You don't want to turn it too high, but then if you turn it too low, then you get a lot of noise.
C'était une...
Pots are nice and clean.
You had to get it to go right foot.
See, there's the station coming in, but the mute's not behaving. Turn it down a bit. With a good antenna, this thing would rock. I really like this thumb wheel. It gives you a lot of precision on, especially now that it's been lubed up properly. It has a really good feel to it. And like this, I said, this quieting meter is ass backwards to what we're used to. Zeros on this side, tens on this side, so. That one's usually a weak station. See, we're not getting it very good. We're not getting stereo on that one.
It's 105.9.
Yeah, looks great.
Yeah.
Really liking this tuner. Be a nice unit to have in the home setup. Anyways, thanks for watching.